In our last module, we talked about the IV curve. In this particular module, we are going to consider 3 points that are very important when you are talking about the IV curve. You can see this diagram is clearly labeled point A, point B, point C, point D, and point E. We want to take a closer look at each of the points. So when you are talking about the IV curve, there are 3 points that you have to take cognizance of. There includes the maximum power points. The maximum power points you can see here. We will talk about what the maximum power point is. And when you are talking, this is the point A. And when you are talking about the maximum power point, it is the maximum power that your solar panel will produce. If you turn to the nameplate of any solar panel, you see that the solar panel is rated in watts. And we know that power is always equal to IV. So your maximum power point is always the point at which your solar panel will produce the highest power if the solar panel is subjected to the standard test condition that we talked about before. But we said that that condition might not be reached in an open field. So this is your point A on this graph, and your point A is a combination of 2 points: the voltage at maximum power and the current at maximum power. I've already said that the maximum power is IV. So for you to have your maximum power, there must be a maximum current and there must be a maximum voltage that the solar panel will reach when they are exposed to the sun. And when you have your maximum voltage at that particular point and you have a maximum current at that instant, if you multiply the two figures, that will give you your maximum power. This is what we are having on the graph. That is your point A, and you have your open circuit voltage. We will talk about the open circuit voltage when considering any solar panel. You can see we are done with point A, point B, and point C. Then you can see point D here is open circuit voltage. Before now, I made mention of open circuit voltage. We will consider the open circuit voltage in detail. What I said before now is that your open circuit voltage is the voltage that your solar panel will have when it is not connected to any load. So we will talk about the open circuit voltage. The essence of this is so that when you look at the solar panel, you know exactly what each of the parameter on the nameplate depicts. So this is your point D on the IV curve, and we have the short circuit current, which is this point. then those are 3 points that are very, very important when you are considering the IV curve of any solar panel. So it's paramount you understand how this IV curve came about. And when you understand the IV curve, that it was conducted in it wasn't conducted in an open field, rather, it was conducted in a laboratory under standard test condition, which we have already listed before now. You get to understand or appreciate the information that is on any solar nameplate. And if you go to buy your solar panel, you go there with your multimeter. We have already elaborated on ways that you can use to know that, okay, this solar panel is not a fake solar panel. This solar panel, with what I have on the nameplate here, if I test it with my multimeter, apart from the physical examination of examining the cells and examining the solar panel nameplate, if I test this solar panel with my multimeter and I'm able to arrive at the figures or the data that I'm having here on the solar nameplate, that gives you an impression of how original that solar panel is, because the nameplate had not been manipulated. It will give you a value very close to what the manufacturers printed on the nameplate. But the reverse is the case. If you test, depending, we are saying these parameters, if you expose the solar panel in an open field, you might not really have exact values that are on the nameplate, because those values that you are seeing, they were conducted under standard test condition. But if you vary the condition, you might not likely have the exact value that is on the nameplate. But you use your judgment, to ascertain the originality of such a solar panel when you finish testing it with your multimeter. And don't fail to understand that P is equal to IV, because this is the formula we are going to make use of when we are doing most of the calculation when solar energy or power generation is concerned, because it's always P is equal to IV, where P is power, I is current, and V. Let's take a look at this other module. In this module, we are going to talk about the maximum power points that we have on the IV curve. And we already said that when we are talking about the maximum power points, the maximum power points will always be gotten when you have the voltage at maximum power and when you have a current at maximum power. Then this is the IV curve, an IV curve of a 12-volt solar panel. If you look at this particular point, you see point A. Point A is the maximum power point. What do we mean by the maximum power point, or Pmax of a solar panel, or when you are talking about the IV curve? The maximum power point is always gotten when by multiplying your voltage at maximum power and your current at maximum power when your solar panel is subjected to a load. When your solar panel is subjected to a load at standard test condition. We talked about the standard test condition, the 100 watts per square meter irradiance or illumination. That is when the solar panel is subjected to that particular condition and a cell temperature of 25 degrees Celsius. That is another condition that your solar panel will be subjected to, and it is under a load. Your solar panel is connected to a load. It's not at open circuit condition whereby the solar panel is not connected to a load and a 1.5 atmospheric spectral condition. So if you subject your solar panel to those conditions and that solar panel is connected to a load and you test the power that that solar panel will produce, the power rating on the nameplate will correspond to the power that you will have when you make use of your multimeter. So the maximum power point is the point where your solar panel will produce its maximum output power under load. Remember, this is very important. You have to make sure that your solar panel is under a load. Under a load, the solar panel is connected to a load at standard test condition. That means the condition that the solar panel will be subjected to there is going to be the standard test condition that we will have. If you subject your solar panel to those conditions and you test the power output that you will have, that will give you the maximum power of that particular solar panel, and it will correspond to what would be on the solar panel nameplate. We will talk about the solar panel nameplate when we are done with the IV course. So when you subject your solar panel to such a condition, there will certainly be a voltage. That is, there will certainly be a voltage. That will be the voltage at maximum power. That means when you are having a maximum power, there is a voltage that gives you that maximum power. And there is equally a current that gives you that maximum power. The voltage at maximum power, point B, and the current at maximum power, when you multiply those two values, that is when you have your maximum power point, and that is equally the voltage at Pmax or the current at Pmax. So that is what maximum power means. When you look at any solar nameplate, we say this solar panel is 100 watts. This solar panel is 150 watts. This solar panel is 500 watts. That means the maximum power that that solar panel will produce if the solar panel is subjected to the standard test condition that we already said something about. So we talked about efficiency. We talked about efficiency of a solar panel. That means if you connect your solar panel in an open field, it might not really give you that rating on the solar panel. It will give you something close to that because it is not under standard test condition. So that will tell you how efficient your solar panel is. That will tell you, that will give you an impression of how your solar panel is. So please, when you see the maximum power, that is the wattage rating of any solar panel that is on the nameplate, get to understand how they come about that maximum power and get to understand how those figures on the nameplate came about. That is what maximum power points, voltage at maximum power, current at maximum power. Let's consider another points on the IV curve of a solar panel. This is open circuit voltage. Open circuit voltage. Before now, we talked about maximum power points, whereby we talked about that is point A, the voltage at maximum power, and the current at maximum power. And you should always know that the voltage at maximum power, because this solar panel is under a load, the voltage at maximum power is always less than the open circuit voltage. We are going to consider open circuit voltage. We will take a look at the solar nameplate so that you see whether the voltage at maximum power is less than the open circuit voltage. We talked about maximum power, that your maximum power is gotten when your solar panel is under a load. So, but in this case, your open circuit voltage is the voltage that you will have when your solar panel is not connected to any load. So it's certainly going to be higher than the voltage at maximum power, because the voltage at maximum power depicts when your solar panel is under a load. So the open circuit voltage is the voltage that is measured across the two terminals of a solar panel when the solar panel is not connected to any load. You have to be able to differentiate between maximum power points and open circuit voltage of a solar panel. This is point D. If you look at this point, we are having voltage at maximum power to be 17, and we are having open circuit voltage to be 21 volts. Remember, we said that a 12-volt solar panel. A 12-volt solar panel will always give you this range, and this is what you might likely have to be the open circuit voltage of on the nameplate and voltage at maximum power on equally on the nameplate. So the open circuit voltage of a solar panel is the voltage gotten across the two terminals, the positive and the negative terminal of a solar panel when the solar panel is not connected to any load. The maximum power was when the solar panel was connected to a load. But in this case, the solar panel is not connected to any load. That is the potential difference across the two terminals of the solar panel when the solar panel is not connected to any load. I don't want to be too professional here because we have some people that are not so rooted. So I will try and make sure that the terminologies I'm using here will cut across every field of human endeavor. I try to make sure that I use simple words to put across my point. So the potential difference across the two terminals of a solar panel, that is the positive and negative terminal of the solar panel, when it is not connected to any load, will certainly give you the open circuit voltage of the solar panel. And we talked about the current at maximum power. You have to equally know that this is always less than the short circuit current. Current at maximum power is also equally less than short circuit current. If you look at this point, you are having current at maximum power to be 2.5 here. That means if you extend from this point to this point, you have your current at maximum power. If you extend from this point to this point, you have your voltage at maximum power. Your short circuit current will always be higher than the current at maximum power. So it is your open circuit voltage that will give you the impression of how original your solar panel is. That is what you have to do. You test the positive probe, link it with your multimeter to the positive probe of the multimeter. Connect we will experiment this in the course of our training. Then you link the negative probe of the solar panel to the negative probe of your multimeter, and you have a voltage. That voltage is the open circuit voltage of that solar panel because it is not connected to any load. So it is very important to test any solar module you want to buy in the market to be sure of the value of the open circuit voltage. Most times, desperate sellers might manipulate the solar nameplate. So if you are able to get to go to the market with your multimeter, you will be sure of what you have when you are buying your solar panel. So when you test the open circuit voltage, that voltage you will have when you connect the positive probe of your solar panel with the negative probe will give you the open circuit voltage of the solar panel. So open circuit voltage of a solar panel is normally higher than the voltage at maximum power. Let's continue. Before we touch about the solar panel nameplates, let us consider the short circuit currents. Short circuit currents, as we see on this IV curve. What do we mean by short circuit currents of a solar panel, or what do we mean by point E on this IV curve? The short circuit current, this is a 12 volts IV curve, a 12 volts IV curve. So the short circuit current is always gotten when you link the positive probe of a solar panel with the negative probe of the same solar panel. That means you link the two probes together. It's dangerous. We will not advise you to do this. When we were talking about open circuit voltage, we were not linking the two panels probe together. We use a multimeter to do the measurement. We will experiment this so that you understand how to test all this in as we progress in this training. So when we are talking about the short circuit current, it is the current that your solar panel will produce when you link the positive and the negative probe together. Please don't try this. You cannot link the positive terminal and the negative terminal of a solar battery together. Before we get to solar battery, you have to understand this. When you are doing your connection, it's good the tools you use should be properly or must be properly insulated to avoid disaster. So your short circuit current will always be gotten when you link the two solar probes together. So before we move to analyzing the solar panel nameplates, let's take a look at how you will know a fake solar panel, as we already know. So we said that it is important. How do you know a fake solar panel? It is important to test any solar panel module we want to buy. Most times when we are buying any solar panel, we go there with our probe, with our multimeter to do the testing. And when we test, as we already expatiated the positive probe and the negative probe with our multimeter, we'll certainly get our open circuit voltage. And we look at the voltage rating on the nameplates, and if it corresponds or is close to the value, we know that this is the original solar panel that we are about buying. So to be sure of the solar panel rating, you have to test the positive and the negative probe of the solar panel with your digital multimeter, and the voltage you have is the original voltage that the solar panel will always produce. So the value of the open circuit voltage gives you the actual value of the rating of the solar panel. Before we move into the solar panel nameplate, there are some parameters there are some data that you are bound to have on a solar panel nameplate. There include, as we have already seen, there include the maximum power we are about delving into the solar panel nameplate. So you expect to always see the maximum power of um, written on the solar panel nameplates, and you expect to see the voltage at maximum power. You equally expect to see the current at maximum power, and you equally will see open circuit voltage of the solar panel printed on the solar panel nameplates, and you will see a short circuit current equally on the nameplate. Those are most of the parameters you see. There must be there, and you will always see the standard test condition. We talked about the standard test condition. You always see the values, the standard test condition in which the solar panel was subjected to in the laboratory before the values that you have on the nameplate is recorded. We talked about 100 watts per square illumination. Then we talked about 25 degrees Celsius cell temperature, and we talked about 1.5 atmospheric spectral condition. So when you look at any solar panel nameplate, you are bound to see these figures. We have more data on the solar panel nameplate, but if you can have a clearer understanding of these parameters that I have put forward, it will guide you to understanding the efficiency or the rating, or you get to know whether that solar panel is a fake solar panel or an original solar panel. We delve into the solar panel nameplates in our next video. Welcome to this module. Here we are going to talk about the solar panel nameplates. First of all, what do we mean by a solar panel nameplate? Some people will say data sheets. If you talk about the solar inverter, we talked about the nameplate of a solar inverter and the data sheet of a solar inverter. Most times you need the data sheet, not most times per se. It's as a professional solar installer, you will always need the data sheet to understand some things about the product that you are buying. So let's consider the solar panel nameplate. What really is the solar panel nameplate? And of what use is your solar panel nameplate? We have already expatiated on the importance of the solar panel nameplate, that without the solar panel nameplate, you cannot configure your system. You don't even know the rating of the solar panel that you are buying. Somebody should not tell you that this is 100-watt solar panel. There must be a nameplate on any solar panel that you are buying. I repeat, there must always be a nameplate on the solar panel that you are buying. This is what will give you all the information about the solar panel, its originality, if you are able to test it. So the solar panel nameplate help us know how we can combine the solar component and the solar panel itself with other components. The data sheet or the solar panel nameplate, it is the collection of information, that is the operating parameters. These are the operating parameters. Operating parameters. So if you don't have the solar panel nameplates on your solar panel, that means there is a problem somewhere. So the data sheet or the nameplate shows you a collection of information that will help end users and installers understand how the products function under certain conditions. We talked about standard test conditions when they were subjected to. For optimum performance, it is the operational manual of the solar panel. It is the operational manual of any solar panel or any gadget that you buy. It's not peculiar to the solar panel nameplate alone. Any gadget, any device you buy, the manufacturers will always put the nameplate. Even though your phone, when you are buying your phone, there is always a nameplate on it to inform you of the parameters, the operational parameters that is on the phone. So this is a 12-volt solar panel nameplate. It's a sun power product. So we talk about the rated power, the maximum power. This particular one that they choose to use rated power is the same thing. So you have plus or minus 3%. What this means, plus or minus 3%, means if you subject this solar panel to maybe you have it exposed to the sun or under standard test condition, like what we already said. Under standard test condition, you can see it here. Standard test conditions: 100 this, 1.5 this, 25 degrees Celsius. That was the condition that this solar panel was subjected to. So if you subject this particular solar panel to this condition, you might have a value that is 3% higher than 100 watts or 3% lower than 100 watts. For the mathematics lovers, if you find 3%, if you add 3% of these watts, you know what you have. And if you multiply 3% of this watts, you also have a value. So that is the value you are likely to have. So this solar panel is rated 100 watts. And the voltage at maximum power, we talked about, we said that for you to have the maximum power, you always have a voltage at maximum power and a current at maximum power. You can see here that this is the voltage at maximum power and it is less than open circuit voltage. So this is the voltage you have. If you multiply this voltage and this voltage, is certainly going to give you something close to 100 watts. We said maximum power is gotten when you multiply voltage at maximum power and current at maximum power. So for you to have this maximum power, if you multiply this voltage at maximum power and current at maximum power, you certainly have to have a value close to this. That means from here, this solar panel should be subjected to a load. That is when you have under this condition. But when you are talking about open circuit voltage. Open circuit voltage is the voltage you have when you are not subjecting this solar panel to any load, and is always higher than the voltage at maximum power, as you can clearly see it here. This is 17.5 volts and this is 21.0 volts. Which one is higher? Because this one is not subjected to any load, it tends to give you a higher voltage. And you have your short circuit current 6.20 amp. It's equally higher than the current at maximum power, and you have your maximum series fuse, and you have the warning here. So this is a 12 volt solar panel, and if you correlate this with what we have on our IV curve, you surely get a clearer picture of how these parameters on these nameplates came about. We are going to bring in a solar panel nameplate of a 24 volt solar panel. Without wasting much time, let's dive into a 24 volt solar panel. We already said that your solar panel can be 12 volts or 24 volts. We talked about how we get to know that this particular solar panel is a 12 volt solar panel, whereas this particular solar panel is a 24 volt solar panel. In the two solar panel nameplates that I have put before you, you have not seen any of them written 12 volts. You have not seen any of them written 12 volts. That means, as a professional, you should be able to differentiate between a 12 volt solar panel and a 24 volt solar panel, because a 12 volt solar panel, as we already said, is used to configure a 12 volt system, and a 24 volt solar panel is used to configure a 24 volt system. If you have a 48 volt system, you can combine 12 volt solar panels maybe in series. It will certainly give you a 48 volt system or a 36 volt system. When we are talking about a 12 volt, 24, 36, 48, and so on, we are talking about the inverter size. If you follow us to our next level of our training, we talk about inverter size. So when we are saying a 12 volt system, we are making reference to the charge controller. We are making reference to the inverter size in particular. So when we say 12 volt system, that means we are using one solar battery. When we say a 24 volt system, we are using two solar battery. A 36 volt system, we are using three solar battery, and a 48 volt system, we are using four solar battery of 12 volt each. So if you want to use a 12 volt solar panel or with a 12 volt, a 48 volt system, you need to series them. That means you have many solar panels connected in series, as the case may be. So before you is a 24 volt solar panel nameplate, clearly shown here. If you look at this, is Jinko solar products. Is one of the products we love using. So you can see the maximum power here. You can see the maximum power here is 465 watts. This is a 465 and 65 watt solar panel. Power measurement tolerance, we talked about plus or minus 3%. We dwell on this in our previous video. There's no point explaining much thing here because we already expatiated on all this. You see, this particular nameplate comes with more data, but we will not go into all this. If you need to understand how all these figures come about, you need to join us in our next training so you can see your maximum power voltage. This might be for the engineers or for the professionals. So this is the maximum power voltage. The maximum power voltage, that is voltage at maximum power. We talked about this. You have 43.18 volts and you have maximum power current, that is current at maximum power, to be 10.77 amp. This one was 43.18 volts. That is the voltage. That is the voltage at maximum power. And this is 10.77 amp. That is current at maximum power. And you have your open circuit voltage to be 51.92 plus or minus. That means plus or minus, I've already expatiated on this, plus or minus 3%. So you might have a value less than this by 3% or a value higher than this by 3%. You equally have your short circuit current to be 11.59 amp plus or minus 4% is applicable to this. That means you can have that. If you do that, then this one is maximum system voltage 1500 VDC. We get to understand this when we are doing system configuration, maximum series and operating temperature. We can have here, these are the standard test conditions in which this solar panel with this nameplate was subjected to before you have these parameters printed on this nameplate. And this is the weight of the solar panel. Well, we want to move to another concept. If you don't understand the nameplates, please try to put a question. You can DM me and you'll be put through with more explanation. But I believe we have done justice. We have done justice to the IV curve of a solar panel. I say we have done justice to the IV curve of a solar panel, and we have equally done justice to a solar panel nameplate. Why do we come up with this training? This training is to assist you understand the solar panel nameplates when you are buying your solar panel. Subway Energy Academy gives you up-to-date information, gives you the secrets in the solar industry, gives you the small details that some people might be overlooking. If you join us in our next level of the training, all the secrets and everything surrounding the solar industry will be exposed to you. And at the end of the day, you will be able to not only make wise decisions, you will be making wise and informed decisions. And at the end of the day, you will guide against costly mistakes that other people are making in the solar industry. And if you are able to guide against the costly mistakes, your solar panel, your solar installation will always stand the test of time. You are guaranteed when you join our training. You are guaranteed when you consult us to install a solar system for you. We give you nothing but the best in service delivery, training, and consulting. Welcome to this module. We are going to look at which solar panel is best for you. We already said that crystalline and thin film solar panels have their own pros and cons. That the choice of a solar panel depends on your budget. So when you are saying I need a quality solar panel, you have to pay higher. We already said that the choice of your solar panel also depends on the condition of your property. How is Do you have enough space to mount the solar panels, or you don't have enough space for the purpose of mounting the solar panels? And your understanding of how the solar panel work. Example, if you are having a limited space, so those living in a dense area with limited space should opt for high efficient crystalline models to make the most of the physical space and maximize utility savings. If you are considering the thin film solar panels, it is best suited for locations where flexible solar installation is required instead of rigid paneling or installation. The thin film solar panels, they don't have frames. Some of them are rollable and some of them are foldable. So in those kind of situations, you might need your thin film solar panels. So we want to move to another concept, which is a familiar concept to everybody that had been in the solar industry, but we are going to adopt a different approach when we are considering types of connection as it pertains to the solar panel. So now we want to talk about solar panels connection. So when you are talking about solar panels connection, it's more or less like solar battery connection. So any solar battery or solar panel connection, when you are talking about connection, you have to consider certain things, uh, you have to put certain things into consideration. First of all, you have to know that your panel connection depends on the current or the voltage requirements that you need to configure other of your components. So you don't just say, I want to connect my solar panels. How are you going to connect it? What are the parameters that you have to take into consideration before you start connecting the solar panels? What are those materials that you have on site that will enable you understand how you connect your solar panels? So if we are considering types of connection or anything connection in the solar industry, we have three basic types of connection, including the series connection. we will take a look at the series connection. Then we have the parallel connection, and we have the series parallel connection. We will do justice to this by throwing more light on these types of connection and how it affects the performance of your installation. But before then, let's look at our nuggets. Let's look at our nuggets. What are the things that you have to consider before you start even planning your installation? If you look at this powerhouse now, you have the Fronius inverters here. You have your Quadros inverters here. You have your Phoenix inverter here. You have your charge controllers here. There are 3 in number. And you have your solar batteries here. Then the question now is, if I am connecting my solar panels, how am I going to connect it with this component that I am having here on site? So the type of connection or the way you connect your solar panels on site depends on the materials that are available on site. You don't just connect solar panels. Solar panels are not connected in isolation. You have to consider the availability of other materials on site. That is the number one thing you have to connect or consider. What is the rating of the solar panel that you want to connect, and how do you correlate it with other components that you have on site? So any connection is based on the panel parameters, that is the solar panel nameplates that we talked about before. Now you have to consider the solar panel nameplate and you match it with the rating of each of the solar charge controller here and the rating of the Fronius inverters here. If you are sending it to the Fronius inverters, if you are sending it direct to the inverter, if it is the inverter that the charge controller is incorporated into the system, that is the inverter, that means you have to equally look at the rating of the inverter before you can think of connecting the solar panel appropriately. And another thing, if you can look at this figure here, you see it connected in strings, string 1, string 2, string 3, and string 4. What informs you of how you connect this in strings, or are you going to connect all of them? This is about 8 solar panels. Are you going to connect them all in series, or are you going to connect them in series and before you connect them in parallel, as you have seen here? So those are some of the factors that you have to consider before you start connecting your solar panel. So we are saying here, before you start connection, you should always ask yourself the best possible ways to arrange your solar panels so that it will be possible to achieve the desired connection. So when you are thinking of connecting solar panels, first of all, think of how many panels am I going to connect? What are the ratings of other components on site? Then how am I going to lay the solar panels? As we have rightly seen here, we are laying it here. This is positive to negative. This is series connection. And we are having string 1. We are also having another positive to negative. And we are having string 2. You see, we have up to string 4. And later, we come and connect all of them in parallel. Then we have the output that we are having here. So those are some of the consideration you have to consider when you are thinking about connecting your solar panel. We move to another nugget that will assist you know how to appropriately connect your solar panels. Thank you. Welcome to these nuggets. We are going to consider another thing that you have to take into consideration before thinking of how you are going to do your connection. We are talking about solar panel connection here, but there are certain things that you have to put in place first before you think about these different ways you can connect your solar panel. The next in this nugget is your roof racking. We have been seeing some people install solar panels on top of the roof without using solar rails. This is our racking system. These are solar rails. What is the importance of using the solar rails? When you are using the solar rails, you help to balance the ambient temperature, because when you raise the solar panel above this roof like this, as you can see, there will be free flow of air, and in such a scenario the temperature of the ambient temperature of the solar panel will be maintained. When you move to a next level of training, you get to understand how temperature affects efficiency. When we were talking about the standard test condition, we were made to know that there is a particular temperature that your solar will operate, and it will give you the required or the specified efficiency of the solar panel. So basically, if you install solar panel without racking the roof, it is very wrong. It is unprofessional. You tend to destroy the solar panel within the shortest possible time. That solar panel cannot last, cannot give you the required warranty as specified by the manufacturers, because you are increasing the temperature that the solar panel is supposed to operate. And when you increase the temperature above normal, the solar panel efficiency will reduce. Before 3 to 5 years, the solar panel will no more perform as it's supposed to perform. So basically, it's very, very important, is professional to always rack your roof. How will somebody have 80,000 naira, 70,000 naira, 50,000 naira to buy one of these solar panels, depending on the wattage? Then the person will not have money to rack the roof like what you have seen. This was a commercial solar installation. If it were to be a residential installation, I believe you might have used maybe 5 or 7 or 10 of these solar rails during your installation process. So it's always very, very important for you to rack your roof like this. So please always ensure that you advise your clients to give you money to rack your roof. So the roof racking will always follow how your solar panels will be wired to give you the required result. In solar installation 101, we talked about the roof, how the roof affects your connection. And when you are having a pitch roof and the different types of roof, we talked about this in solar installation. The type of roof that you have surely affects this installation and your wiring exercise or process. If you have roofs that maybe like this one, we are having 2 planes here, plane 1 and plane 2, there is a way you connect it. There is a way you connect it, and it will give you maximum productivity. If you have different, maybe like this one you are having here, you have different planes. You have to know where am I going to connect it in series. When am I supposed to connect it in parallel? Because the sun rays that will get to each of these um, um, section of the roof, each of this plane of the roof varies. You cannot have the same intensity of the sun here and equally have the same intensity of the sun here in some instances. So when you have roofs of different planes, you have to understand how to connect your solar panels so that you get maximum efficiency. And another thing is, if you having this connection here, always use solar rails. We have said you have to use solar rails when you are talking about your installation. And we are saying when you are connecting your solar panels, you have to ensure that wires are of the same length. If you can take a look at our own connection here, we ensure that these wires are of the same length and the output wire here is of the same length. So always ensure that the wires are always of the same length, and make sure that when you are planning your installation, you get to understand how many planes do I have. If you are going for an industrial or a commercial solar installation, and the roof system, the type of roof is the one that have different planes. We talked about this in solar installation 101, how the different planes or the different types of roof that we have will affect how we connect the solar panels. It will definitely affect the output that you have when you are connecting your solar panels. So always ensure that you take all these things into consideration before you start connecting your solar panels. And if you want to really get the best out of your installation, ensure that you rack your roof appropriately so that the temperature below, that is the ambient temperature surrounding the solar panel, will allow the solar panel have or deliver the required power as it was specified by the manufacturers. We move to another nugget that will help us know how we are going to plan our own connection effectively to deliver the required power output when we are talking about solar panel. Welcome to this module. We are going to take a closer look at series connection. What do we mean by series connection and how are panels connected in series? Then you have to know that when solar panels are connected in series, we are going to bring in an example so that we see how solar panels are connected in series. We are saying that when solar panels are connected in series, output voltage. We made mention of what voltage is before now. The output voltage will increase while the output current remain constant. So during series connection, it is the voltage that will normally increase, whereas the current will always remain constant. When you are talking about configuring system, you have to consider the voltage of other components and the current of other components. What is voltage and what is current? It is something that everybody already knows about. Solar panels are connected in series. When the positive terminal of one solar panel is connected to the negative terminal of another solar panel. When you link the positive probe to the negative probe of another solar panel, that is series connection. That is series connection. Simply link the positive probe of one solar panel terminal to the negative probe of another solar panel terminal. You have successfully connected the solar panel in series. Series connection is done to achieve a higher voltage. When you are trying to achieve a higher voltage, maybe depending on the voltage of the battery or the voltage of the charge controller or the voltage of the inverter, you have to know how to connect, whether you want to connect it in series or in parallel. We are not talking about system configuration here. We are only considering how to connect solar panel in series. Let's look at example 1. If you take a look at this example, you can see that this is a diagrammatical representation of solar panel. So let's go with this. Assuming this solar panel is 50 watts, each of these solar panel is 50 watts, and you want to connect them in series, what will be the resultant watts of the after the connection? And assuming this is your positive terminal and this is the negative terminal of this particular panel, you are connecting the positive probe of this panel to the negative probe of this other panel. You are connecting the positive probe of this panel to the negative probe of this other panel. You are connecting the positive probe of this one to the negative probe of this one. At the end of the day, you will have the positive probe remain here and you have the negative probe remains here. What you have actually achieved now is a series connection. And we said that when solar panels are connected in series, what happens? It is the voltage that increases. But in this case, we were considering solar panels of the same wattage and you are connecting them in series. When such happens, the total watts will equally increase. The total watts will equally increase. So when if you say 150 plus 150 plus 150 plus 150, that will give you 600 watts. And you can see a string of if a string of 4 solar panels of the same watt connected in series. That is what we are showing you here. Then we are saying that panels of the same watts, when panels are of the same watt, we will talk about connecting solar panels of different watts or different voltage or different currents as the case may be when the panel parameters are not the same. How do you go about what would be the effect of what we advise? It is not professional to connect solar panels of different ratings. Is good if you want to connect. You always go for panels of the same ratings. So we are saying that panels of the same watt, when connected in series, the output watt is the addition of each of the individual watts of each of the solar panel. So what that means is, if you are having 150 watt solar panel, 150 watt solar panel, 150 watt solar panel, and 150 watt solar panel, and you connect them in series, at the end of the day, you have 600 watts output. And that means if you were to use a 600 watt solar panel, you only need one. But and that one solar panel will be a 24 volt solar panel. But in this case, that you are using a 150 watt solar panel, you can see this is a 12 volt solar panel. That means you use it on a 12 volt system. I don't know whether you are able to correlate the information that we are passing here. If it were to be a 24-volt system, you can go for just one solar panel that is 600 watts. You can go for just one solar panel that is 600 watts, or a 300 watt solar panel. And if you equally need 600 watt output, you will need two of it. That is how we go about the business. And we are going to bring in more illustration to illustrate series connection. Watch out for our next module. Thank you. This is example 2 when we are talking about series connection. If you look at this solar panels rating, we still have 4 solar panels. There are all of the same watts. Each is 152 watts. And each is 19 volts, 8 amp. And by what we are discussing here, we said if we connect the 4 solar, if you multiply 19 volts times 8 amp, it will give you 152 watts. That is what you have to understand. We said this when we were talking about solar panel nameplate. So if we are having 4 solar panels and each is rated 19 volts, if we connect it in series, you will have 4 times 19 is equivalent to saying 19 plus 19 plus 19. So 4 times 19 will give you 76 volts. We said when we connect solar panels in series, the voltage will increase. The voltage will increase. The voltage is additive, but the current will remain constant. And this is still 8 amp. That means we are still having 8 amp when we are connecting these 4 solar panels in series. What will be the power? What will be the power? The power here will be, we are having total power. You should recall that P is equal to IV. Total power is equal to the voltage. The voltage multiplied by the current. What will be the total power that these 4 solar panels will generate if you connect all of them in series? Each is 152 watts. The total voltage in series will give you 76 volts, and the total current remain constant. If you multiply voltage times current, that will give you power. That will be 608 watts. Is equivalent to saying 4 times 152. 4 solar panels times each of the wattage of the solar panel. We already talked about this in our last video. So that is the result that you will get. We are not considering how to configure this with other components. We are just trying to consider how we arrive at the total output, or what will be the resultant voltage and what will be the resultant current when you connect solar panels of the same ratings in series. Remember, we are considering series connection here. So we are saying when we have 4 solar panels, each as rated on this, then the result is what we are having here. And this is exactly what I have already explained. You can go through it and get a clearer picture of what I am saying here. We go to example 3. Example 3 is the figure before you here. This is another solar panel with a different rating. Each is rated 12 volts. We like using panels of the same rating. We don't mix solar panels that are not of the same rating. It will certainly affect the output, the total output that you get. 12 volts each and 5 amp each. And if you multiply 12 times 5, it will give you 60 watts. That means each of these solar panel is 60 watts, and we are connected. This is the negative terminal. We connect it with the positive terminal. This is the negative terminal. We connect it with the positive terminal, and we are showing you that we are using MC4 connector here. This is 1, this is 2, this is solar panel 3. And if we use a multimeter, to test the output, we link the positive terminal of this other solar panel to the positive probe of the multimeter, and we link the positive terminal of this other panel to the we link the negative terminal of this other panel to the negative terminal of the multimeter. We link the positive terminal of this other panel to the positive terminal of this the multimeter. We will have we will certainly have 180 watts. We will have 36 volts, and we will have 5 amp. We are talking about series connection, remember, and we said that when you connect solar panels in series, the voltage is additive. If you add 12 plus 12 plus 12, it gives you 36. And if you are connecting solar panels in series, the current remains constant. You can see from here that it is still 5 amp, and you are having 36 volts. That the total power that you will have will be what? The total power you will have will be what? Will be 180 watts. What if you do not go through this? You just say 60 watt times 3. That will still give you 180 watts. That is how you get to understand how to connect solar panels in series. The same principle holds for any solar panel connection in series when the ratings are of the same. Even though you have 1,000 solar panels and you connect them in series, that is, the voltage will always increase, but the voltage will be too much for you to send it to a component. So you will certainly have to divide them into different strings, and we divide them into different arrays, and we know how to send them to the component that we want to send them to. Then that is how to connect solar panels in series. Connect the negative terminal to the positive terminal, connect the negative terminal to the positive terminal, and the remaining probes will always be linked to the output. And if you read the output, it will give you a higher voltage, and the current will always remain the same. Thank you. Welcome to this module. Here we are talking about parallel connection, and we are telling you that when solar panels are connected in parallel, the output voltage remain constant. Remember, when we were talking about series connection, the output current was what remained constant, whereas the voltage increases. But in parallel connection, the output voltage will remain constant, while the output current will increase. Then solar panels are connected in parallel when the positive terminal of one solar panel is connected to the positive terminal of another solar panel. When we were talking about series connection, it was the positive terminal of one panel that was connected to the negative terminal of another panel. But in parallel connection, the positive terminal of one panel is connected to the positive terminal of another connection, as we will see in the course of this training. And we are saying that parallel connection is done to achieve a higher current. If you need a higher current to charge maybe your battery, or as the case may be, depending on the specifications of the component on site, you should know how to connect your solar panels. Then we'll take a look at example 4, assuming we are connecting solar panels of the same watts. You can see here solar panel 1 is 150 watts, solar panel 2 is 150 watts, and we connect all of them in parallel. What will happen? We are bound to have 600 watts. That is what you have. We are saying here that panels of the same watts, when connected in parallel, the resultant power is additive. That means if you are connecting solar panels of the same watt in parallel, you are bound to have addition of all the wattage of the solar panel. We look at example 5 here. What really happens here is we are equally having 4 solar panels here. You can see we are connecting the positive to the positive to the positive to the positive. That is parallel connection. We are using this diagram to illustrate parallel connection, and we are connecting negative here, negative here, negative here, and negative here, and that is parallel connection. We are connecting the negative of one solar panel to the negative of another solar panel to the negative of another solar panel, and we are using a uniform output cable. And if you equally come here, you can see we are connecting the positive here, the positive here, the positive here. We link all the positive together, and we link all the negatives together here. That is parallel connection. What happens when you connect those panels like that? If you look at this, our output here, you have a total voltage of 19. Each of these panel was 19 volts. If you connect all of them in parallel, there will still certainly remain 19 volts, and the current will be additive. That means 8 amp times 4. You can see it here. 8 amp times 4. That will give you 32 amp if you do the calculation. That means we have successfully increased the current, whereas the voltage remain 19 volts. Then we are saying that the above connection represents 4 solar panels, each rated 19 volts, 8 amp, and 152 watts, all connected in parallel, and the resultant voltage, current, and power of the parallel connection. So by now, you should understand and you should be able to explain to somebody the difference between series connection, the difference between parallel connection, the difference between connecting a solar panel of the same watts in series and connecting panels of different watts in parallel. This is Subway Energy Academy, one of the leading training platform that you can trust. We are going to move to another module in which we are going to talk about series parallel connection. If you have any question, if you don't understand the concept, do well to DM using the WhatsApp number, and you will be guided accordingly. We throw more light on this. If you are interested joining our master class, you will be informed accordingly, and a trial will always convince you. That is how to connect your solar panels in parallel, and how to go about connecting your solar panel. This is example 6 of parallel connection. You can see here diagrammatically we are connecting all the positive probes of the 3 solar panels together, and we are connecting the negative probes of the 3 solar panels together, and we have this result that you are having here. This panel is rated 12 volts 5 amp. When you connect them in parallel, the voltage will remain the same, whereas the current will increase. This is what we have just finished discussing, and the same principle holds for any solar panel connection in parallel. When the ratings are all the same, there is no variation. When the solar panels rating are of the same size, then we are taking a closer look at series parallel connection. We talked about series connection, we talked about parallel connection. Now we are talking about series parallel connection. That means when solar panels are connected in both series and parallel connection, 2 things will always happen. You have to know that. And you have to know that during series connection is the same principle that, like what we have already discussed. When panels are connected in series, the voltage of the solar panels connection will increase while the current will remain constant. And during the parallel connection, the current of the solar panel connection will increase while the voltage will remain constant. And you have to always know that I don't know what other people do. We normally connect our panels in series first before we connect them in parallel. What I mean is, we first of all connect the panels in series before we connect the panels in parallel. So we are saying that depending on the voltage and current required, solar panels can be divided into different strings. We know what a string is, and connected together in series to increase the voltage. After that, the different strings are connected in parallel to increase the current, thereby forming solar array. This is a string, as we already see. This is negative to positive. This is series connection. This negative to positive series connection. This is the first string. The same thing happens here, and we have the second string here. The same thing happens here. We have the third string here. And the same thing happens here. We have the fourth string here. And we later connect all of them in parallel by linking all the negatives together. And we connect all of them here by linking all the positives together. And we have an output here. That is series parallel connection. We first of all connect them in series, and we come and connect them in parallel. And we have to look at this example as we bring this figure before you. These solar panels are of the same rating. They are of the same rating: 12 volts, 5 amp, 600 watts. You can see we are connecting the negative to the positive. That is series. The negative to the positive. That is series. The negative to the positive, and the negative remains here, and the positive remains here. We come here, we connect the negative to the positive, the negative to the positive, the negative to the positive. That is series connection. And the negative remains here, and the positive remains here. So we come and link the negative of this one to the negative of this one. We are using this bigger wire to do the output, and we connect the positive of this one to, we link. If it was in real life, we will always use our MC4. We said this before we start talking about connection. So we would have used the MC4 here before we send this output that we are having here. And before we send this output, we use MC4 for the connection here. Then you have to understand that when we are connecting the first string 1 output, what will be string 1 output? What will be string 1 output? We are having 12 volts. They are connected in series. 12 times 4, that will be 48 volts. They are connected in series. Current will remain constant. That will be 5 amp. And if you multiply these two, that will give you 240 watts. That is the output power you will have if you test it. If you link the positive here and the negative here, this will be the output power that you will have. That is for string 1. And you keep it. You do likewise for string 2. And if you test output that you have here and the output that you have here, it will give you 48 volts, 5 amp. That means you have successfully connected string 1, you have gotten the output. You have successfully connected string 2, you have gotten the output. Then you link the two strings together. It forms a solar array. It gives you this total output that you are seeing here. If you have that remember, the voltage will remain the same, because now we are connecting it in parallel. The voltage will not change. It will still be 48 volts. Since we are connecting it in parallel, remember we first connect them in series and keep. Then now we come and connect them in parallel. We come and connect them in parallel. Here was 5 amp, 5 amp. That will be 10 amp. That is what we get. And if you multiply 48 times this, will give you 480 watts. That will be the total power if your solar panels were rated like it. It's very simple. It's very simple. So that will give us the output, the total output of the entire array here. This is an array now, but this was a string. This was a string. Then we connect the two strings together and it forms an array, the total array output. Thank you for welcome to this module, example 9 of connecting solar panels in series and in parallel. We are having a 4x3 configuration here. Why do we say it's a 4x3? You can see this is 1, 2, 3, 4 solar panels by 1, 2, 3. That means 4 in series and 3 in parallel, depending on the rating. You can see 0.5 volts, 0.5 volts, 0.5 volts. These those are the ratings of each of the solar panel. And this is your string 1, this is your string 2, this is your string 3. And at the end of the day, this is each of them is 0.4 amp. Then let me calculate on this. Welcome to this module, example 9 of our series parallel connection. We are having a 4 by 3 configuration here, a 4 by 3. That means we are having 4 solar panels connected in series, and we are having 3 series connected in parallel. Each of the solar panel is rated 0.55 volts and they are rated 0.4 amp. And when you connect them during the series connection, you are bound to have an increase in voltage, and if you multiply the voltage, you get 2.2 volts. That will be the voltage that the entire array will give. And if you come and connect all of them in parallel, look at positive, 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 you have 1.2 amp. That is for 0.4 times 3. That is the amp you have. And what will be the power? Remember, power is VI, voltage times current. That will give you 2.46 watts. This is the positive terminal, and this is the negative terminal. This is the array output. If you test it with your multimeter, 4 sets of cells in series, 1, 2, 3, 4. That is 4 sets in series. 3 groups of cells in parallel. String 1, string 2, string 3. That is what you have if you connect such panel in series and in parallel. We are taking a closer look at another example, which is example 10, still on series parallel connection. We are having each of the solar panel here rated, as you can see. By now, we are using MC4 connector to do the connection. We are connecting the negative to the positive, and we are equally connecting the negative to the positive. And this is string 1, and this is string 2. We come and connect the positive of this one. We link it to the output cable, and we link this one to the output cable here. This is pictorial illustration. If it were to be real life installation, we would have used MC4 connector. When we move to the practical session, we will show you how to go about this, and you get to understand. Each of the solar panel here is 12 volts, 12 volts, then 4.0 amp, 4.0 amp. It will give you 24 volts. 24 volt, that is 12 volt, 12 volts here is 24. Then 4 amp here, 4 amp here. The first amp will be 4 amp from this series, and from the second series will also give you 4 amp. And when you connect them in parallel, it will give you 8 amp. That is how we do it. That comes to the end of connecting solar panels of the same ratings in series. We first of all start by letting you know that there are some things you need to consider before you start connecting your solar panels. There are some things you have to consider before connecting your solar panels. We made mention of those things. We move to talking about series connection. What is series connection? It is a connection whereby you connect the positive probe to the negative probe of another terminal, of another solar panel, not the same panel, please. Then we move to parallel connection. How do we connect solar panels in parallel? Connect the positive probe of one solar panel to the positive probe of another solar panel. That gives you parallel connection. This was series connection, as you can see here. This was series connection. We connected two of these. We connected two of these. The negative will be out here. The positive will be out here. The positive will be out here. The negative will be out here. Then we come and link them, and that give you series connection and parallel connection. That is the types of connection you have when you are talking about solar panel connection. Then connecting panels of different ratings together. Well, we don't like talking about this. If you are able to get our textbook, you will see the effects. What will happen when you connect solar panels of different ratings together? We are saying that it is unprofessional to connect panels of different ratings together, because it will either affect the voltage or current of some of the solar panels, thereby affecting the outputs of the connection. So, as a professional, always guide against connecting panels of different ratings. Not that it cannot be connected. If you get a copy of our solar companion, you get to understand how the connection is done and the effects you will have when you connect solar panels that are of different ratings together. What will happen to the current, and what will happen to the voltage. This is our online training course, Subway Energy Academy, one of the leading training academy you can ever imagine. When you move to our next level of our training, we will show you nothing but the secrets when it has to do with anything concerning solar energy. We are professionals in the field. A trial will always convince you.
This lovely home outside Denver, Colorado suddenly went up in flames.
I have a fire. I need the fire department here.
Inside your house?
Yes, inside my house.
Hang up the phone and evacuate the residence.
The newly furnished 4-bedroom, 3-bath home with a nice kitchen was completely destroyed. And you won't believe what caused the fire. An ordinary 9-volt battery like these, the kind we all have in our homes.
Never thought in a million years that that could be the cause of the fire.
David Miller made a habit of tossing old batteries in a paper bag in his garage for recycling later, including the 9 volts he used in all his smoke detectors. But little did he know, there's a small but hidden danger. 9-volt batteries can cause a fire in a very unexpected way. It can happen when metals like steel wool touch both the positive and negative terminals at the same time, creating a current. This can cause sparks and heat up the battery.
You apply a 9-volt battery, this is what you get.
Just check out these videos online. 9 volts are used as a quick method to start fires outdoors.
Apparently one of the batteries came into contact with another, and a couple hours later I had a fire in my garage.
Fire investigators dug through the rubble in the garage and found the burned out batteries. You can still see their outline.
You can see the square shape of the case here, and right behind it there's a second battery.
So how dangerous can 9-volt batteries be? To demonstrate, we had Nassau County, New York Fire Marshal Vinnie McManus simulate a fire that can break out inside anybody's junk drawer.
When the battery is in a drawer and comes in contact with other metal objects, that's where that spark can occur and the fire can happen.
First, the drawer smokes and then quickly goes up in flames.
You can see a simple fire in a kitchen drawer, how quickly it can extend to involve that whole cabinet and the upper cabinets and cause amazing devastation very quickly.
There are steps you can take to avoid a fire. First, always keep the batteries in their packages before use. Second, don't carry 9-volt batteries in your pocket. Keys and coins can short the battery. And third, cover the terminals of all loose batteries with a...
Some video. You can see this, guys. This is Canadian Solar 350 watt. This is Canadian Solar. See the real, and it's 250 watt. You see what people can do. You see? Can you see this? Can you see this? Can you see this? I'm sure that's it with other panels also. Wait, bring this panel. Let's check again. Oh, see the same thing. This one is what? 250. My God.
There are even different.
Okay, this is Jinko. Can you see that? Oh my God. Can you see what?
And the man was saying he doesn't want Jinko. He doesn't want Jinko.
You see this one? 250 watt, 300. Can you see? And it's even 60 cells. You see, this is how they dupe customers. This is how they dupe customers. Can you see that?